In this segment, we'll look at string or varchar data types. And before we discuss them, the string types, let's look at two major issues that are involved in storing strings. The first is that strings may be of varying or of fixed length. Last names, for instance, can vary from 2 to perhaps 30 characters, but state abbreviations are always exactly 2 characters. If a string column is of fixed length, then we can reserve a guaranteed number of characters for it, and we don't need to store its length along with each string value. But if a string column is of varying length, then the string's length must be recorded along with its value. SQL doesn't use end of string markers, by the way. It stores string length directly. And then the second issue is that longer strings, the length of longer strings, that is, takes more bytes to store. A last name is never more than 255 characters, and so only 1 byte is needed to store its length. But a user comment in a web review would probably exceed 255 characters, but on the other hand, one would at least hope would be limited to at most 64K characters. Its length could thus be stored in 2 bytes. And even longer strings would require 4 bytes. Now, before we look at specific string types, load up the bakery3.sql file, the first part of which is shown in the notes here. And as you can see, we've added a number of new fields to customer, and these illustrate string types. Now, let's talk first about char n. This SQL standard type reserves a fixed number of bytes, the n value, for a string column. Any string stored in the column must have exactly n characters. If it has fewer, then blanks get added at the end. So in the Bakery 3, we're using char2 for a state abbreviation. As another example, we might have declared our product IDs to be char 15 because none of them ever exceed 15 characters. If we do this, then any product ID of less than 15 characters would get blank padded. And if it had more, then under MySQL it would get truncated to 15 characters. A fixed string length makes allocation of disk space for the strings more efficient. So use char n when you're sure of the number of characters in a string. For instance, if it's a state abbreviation or a social security number or a credit card number, which are usually stored as strings, not numbers. It can still be worthwhile to use char even if the string length varies a bit, for instance, a license plate number. The cost of an occasional extra blank or two to pad short strings is worth the advantage of predictable size. But if string length varies significantly, then use varchar n. Which brings us to the other major string type in SQL, varchar. A varchar n declaration is a standard SQL type, and it allows strings of up to n characters in the string column, but it does not pad with extra bytes. Instead, it uses only as much space as needed for each string, not even n bytes, not even, for instance, 30 bytes, if the actual content is shorter than n. Now, at first glance, this sounds better than the blank padding of char n, and one wonders why you'd ever use char n. Well, there are 2 reasons, already kind of implied above. First, varchar n columns must store the string length along with its content. It's just an extra byte or 2, but that matters when a table has millions of rows. And more importantly, the variability of length makes it harder to allocate and manage storage for varchar columns than for char columns. And the reason that varying length strings present a storage hassle are a bit subtle, but here's a quick analogy for you. Imagine having to arrange shelf space for boxes in a storeroom with many shelves where each shelf is of fixed width, and boxes often are removed and replaced by other boxes. Now, if the boxes are all of identical width, this isn't so bad. The shelf space left by one box can be filled neatly with another. But if their widths vary, the problem gets much harder. The shelf space left by a smaller box won't fit a larger box, and putting a small box into a larger space leaves leftover wasted space. With varying sized boxes, the storage space tends to degenerate into a hodgepodge of spaces, many of them too small to fit any box. And then the empty spaces tend to get scattered around when you'd rather have them grouped together to accommodate large boxes. It would be nice if you could move them around to concentrate the open space, but sometimes that's not easy to do. So, connecting this analogy to disk and strings, the shelves are disk blocks of perhaps 8K bytes. The boxes, of course, are the strings. And the difficulty of moving or copying them around is due to the slowness of disk. The tendency for open space to degenerate into lots of individual smaller spaces spread out around the storage area is called disk fragmentation. So, if you can standardize your strings by setting a fixed length for them via char_n, you'll help the DBMS avoid data fragmentation or disk fragmentation. Fixed size boxes are always nicer. But if the fixed sized boxes are mostly filled with air, with blank padding, then that defeats the purpose, and you may as well go with varchar instead. Now, if you're choosing varchar n, why make n small? Why not just declare varchar 1,000,000 and be done with it? Remember, the n is just an upper limit, so a large n would give you maximum flexibility without blank padding. Well, first, the size of the length for a varchar does depend on n, as we emphasized earlier. Smaller n value reduces the number of bytes needed for the string's length, and if it's less than 255, just 1 extra byte per string. If it's less than 65,535, correct a small off by 1 error there. If it's less than that, then we need just 2 extra bytes, less than or equal. For larger values of n, as we know, it goes to 4 bytes. Now, reducing the bytes needed to store the string length seems like a minor issue, but that's not necessarily so. Come up with a reasonable example where using varchar 256 instead of varchar 255 would on average increase the storage needs of the column by 10% or more. If you think about it, you need to have a column that generally has smaller data. A column for first name would be a good example, really, like we have here. First names average probably less than 8 characters in length on average, though this might exceed 20 or more. So a varchar is in order, but using 2 bytes to store each name's length instead of 1 will increase average storage size from, say, 8 bytes to, or 9 bytes, counting the 1 for length, to 10. And that's over a 10% increase. So then why not just use varchar 255 for any case where 255 is enough? That's probably 95% or more of string columns. You'd get the 1 byte length for the string, but maximum flexibility. Thus. So, question 2. You actually do see a lot of varchar 255 columns in databases for just this reason, but it's usually sloppy design. Why? And if it's not obvious, review the 3 design issues discussed in column types overview at the start of this general topic. One of them in particular applies to this question. So the answer here is that if you're sure a string should not exceed some length, it's best to specify that length to help the DBMS catch errors. For instance, varchar 30 for a first name column will allow any possible first name, but would catch a bug or a careless data entry clerk that tried to put 100 characters in a first name field.